Hello! And what we're going to be doing today is we're going to be looking at this device from Lee, one of my viewers, and we got talking about CNC, so he's been doing some CNC work, and he had a board from a CNC machine a lot like mine. So this is his spindle control board. We've got the potentiometer there, and this board, he's had some problems driving a motor. Now he's using another board temporarily, but it is very similar. This is the CnC board.
It's so tiny.
Maybe we need to get this under the microscope. What do you think, John?
Yeah.
So this board is a CnC, and it's a spindle control board. That means, just like this machine here, the CNC, the spinning motor on a CNC that allows it to cut stuff. And it's got to spin that motor very quick because that's how it actually cuts everything. So, let's have a look. This board is
PW 3618.
PW3618. The fuse is dislodged, so let's just pop that back in. But I believe Lee was saying it was permanently on. I think he said there was a blown resistor on it, so I'll maybe find some pictures of that and what it looked like originally. The blown resistor suggests something else was wrong and too much power was going through this board at some point. So this is one of the most important chips on the thing.
555?
Yes, so the 555 timer chip. You put power in, and what it does, yeah, if you put the right circuits around it, is it goes like that with the power. Makes it go up and down over time. Okay? Now what we're going to do, we're going to use this over here to look at this board and figure out what is wrong with it. So we want to see if there's power coming out of it. Over here where power would come in, we've got some places here where you can control it and get outputs, spindle outputs and other power outputs over here. So this circuit here, John, turns power from a socket into power for this board. We're going to bypass that and use our own power supply to get the power to the board, and we're going to check just that we're getting the timer out on the board. Let's get it powered up. Now, what do you think this would do, John? Any idea? Try turning the knob, see how it feels.
Oopsie.
So this knob, John, you would plug it into this and it would control power coming out. Because what it does is it turns the power on many times a second, and the longer it's turning the power on, the faster that the spindle on the machine there will spin.
Yeah.
But if it's actually putting it on all the time, then the spindle will turn too fast, and if it turns too fast, it'll use too much power, and if it uses too much power, something goes bang. And if it's not putting out any power, then guess what happens? Nothing. Although it's vaguely different, this is pretty much the same diagram. And what I'm looking for here is somewhere I can put power in. The negative terminal here should be the same for all grounds. So all the grounds are going to be tied wherever you see this symbol. But then we're looking to see if we can get a positive power input here. So here's the 555. We've got the variable resistor across these two diodes, so it will load and unload the power on the 555 through that resistor. So that goes down to ground through this capacitor, so it kind of loads a capacitor and then discharges it, and that creates your timing circuit. Now there's a 7812, so the output of the 7812 I think is providing your power to your 555. So pin 3 is a discharge, so I guess we could attach our probe there and see what we get with pin 3. I'm going to attempt to do DC power around this net here, and we'll see what we can find out. Oh, and in case you're wondering, we have lost Jonathan. There is snow outside, so he's gone to play and build snowmans, which I thoroughly approve of. I thought I'd go and join in and build some snowmen too. So, snowmen. So I have this board wired up to some power, and I've not really played with the potentiometer yet. I'm going to go on pin 3, 2, 1. On the 555, pin 3 should be output, but pin 7 should be doing something. So those pins are all stuck high. Potentiometer around and see if I get any PWM. Oh, expecting to get PWM here. It's not generating a signal. I'm going to turn it off now. But this board is not producing any PWM at all. So Lee, you're absolutely right. This board does nothing. And I guess I'm going to start probing with a multimeter to see what is going on. Just in case you were wondering, you should have seen a nice square wave on the oscilloscope here. Seeing nothing, that's a really bad sign. I check that there's nothing feeling hot. Oh, there is a bit of heat. This was the switch. We see that. I wonder if that's going to that 4N25 over here, to the opto instead. By looking at the traces, I have validated that the switch here, being on this side, that trace follows it through to going to the potentiometer, so it is the right side, not to the opto. I'm going to verify the potentiometer connected on my multimeter. So I've stuck it in the 20k range, and we're getting 4.99, and if I vary the dial, then the numbers change. Okay, if I try the other side, 2.14, and if I vary the dial, it varies as well. So I have no doubt that the potentiometer is just fine and is not the cause of the problem here. There's nothing wrong with the potentiometer. So it's either got to be the 555, which gets very hot when doing this, or one of these other parts around the 555 circuit. I've decided to go and desolder the 555 and replaced it with an IC holder. So what that means is I can drop in another 555, and also I can take the 555 from the original, drop it onto a breadboard and an LED, see if I can make that work versus one that's fresh out of a tube. And I can see, well, is it that this one is blown, or is it that there's something else wrong? Jonathan, we had a talk about waves, and you remember what this kind of wave is? This shape?
Square wave.
That's a square wave. And then do you remember what this curvy one was?
Sine wave.
And we've got some squiggly waves that we can put on top of sine wave. But today we're talking about Lee's spindle module for his CNC, which uses square waves, which is what PWM, pulse width modulation, changes the shape of these square waves. And we took the 555 and we put it into a circuit. What do you think this circuit's going to do, John?
I don't quite know, because I don't remember the last video when we played with it.
Okay, let's talk about what the pieces are. So this bit here at the top, this is a power supply.
I think I know what it is. A circuit.
This is a circuit, correct.
But not a Raspberry Pi.
No, it's not a Raspberry Pi. So this bit at the top here is power. Yeah? So we've got power going into my circuit for me to do stuff with. There's a button here to turn on the power. This bit here, we've got a dial here so we can change something. We've got a capacitor. The capacitor is, it stores power and then stops after a while, and it can let power go and stops after a while, so it gives you time. But this is what we're testing. So this here is the 555 chip. And you remember the other 555 was getting very hot. I did test it in this circuit. It did nothing. It got so hot I thought I better take it out and throw it away because I didn't want to have a brown board syndrome. So this circuit, when I turn it on, you're going to like this.
It lights up.
It's not just...
That's called a wave.
The wave is coming out on the LED, isn't it? It's turning on and off very quickly.
Yeah.
So what's happening is, through the 555, it's putting power through this blue thing, which is called a resistor. It's a resistor we can change value of, to this thing here, which is a capacitor. I've set it to a value so we can just about see the blinking of this light. But look at these. Do you know what these are?
I don't know if it's from one of this.
We've got one.
Let's find out.
Let's find out. Okay, no, I love that. That's the best way. All right. This thing is called, it says on it, can you read the word on there, John? It says, yep.
Logic analyzer. Logic analyzer.
Correct. This is a logic analyzer. Now, the logic analyzer allows you, just like the oscilloscope, to look at waves. But the logic analyzer can only really look at square waves with different speeds and different timings. So, this here is our logic analyzer. And this channel 0 is what's connected to that red pin. So what we're looking at here is the wave. And can you see we've got an on time and an off time? The off times are longer over this side than they are on the other side.
Yeah.
So what that is telling me, this is a real square wave coming out of this real board. Let's turn it on and do it again. So if I press start, we'll make it record a new square wave. So it's just recording from this board through this into the computer. There we go. There's a square wave. So it's going off and then on. So that's the wave for real on the computer that's coming out on this red bit here. And look, it's even telling you at the top. Look, it tells you how long it was off and how long it was on for. So look, it was on for 66.7 milliseconds. Frequency is 7.303 hertz, which means about 7 times a second, or 8 times, between 7 and 8 times a second.
I think the 5 is working, Daddy.
I think so too. Look, if we adjust this, we can make it blink at different rates. Look, it can go faster, crazy fast. Or, oh look, now it looks like it's on, but it's not. It's just going so quick you can't see it. Or we can go all the way down here. If we go too far down here, it goes slower and then off. So you're right. I think that 555 is working.
But let me quickly test.
Oh, of course, you can test too. So the blue one. Yeah. Now, see these? I'm going to do one more experiment before we go back to the video content, just because it's fun. So this, Jonathan, here, this big thing here is called a capacitor.
Capacitor?
And we got one in here. So let's turn this off. So you press the off button for me. If I put in a bigger capacitor, do you think the light's going to be quicker or slower? So it'll take longer to get full. So what does that tell you if it's going to take longer to get full?
Fast.
Turn it on, let's see.
Slow.
Slower, because this one takes longer to get full. Now this one is too slow for us to see with a logic analyzer. And you can put it right up to the highest speed. So if you go this way, it's higher, faster. Yeah, that's as fast as it's going to go. And you see it's just turning off. Tiny little flickers going off, but they're maybe nearly every second. Now, what if we put a really tiny capacitor in? So this one, it says 103. It's nearly 100 times smaller than the other one.
I don't know.
So this one, let's put it over here where we can actually see a fairly good square in the middle. Okay, turn it on and tell me if you can see the LED changing. It just looks on. Do you think there's a wave there or not?
No.
Okay, should we see what the logic analyzer says? Because there might be a wave too fast for us to see.
Yeah.
Okay, let's hit the start button on the logic analyzer. And look at that. It's not up, it's not down. It looks like one thick, fat, white line. What do you think is going to happen if I zoom into that line? Still a white line? Oh, look what that white line really is.
A wave.
Yes, but it's so fast that our eyes just think it's on. That's faster than our eyes can see, but it's a wave.
Right, high five.
Now we can see waves with the computer that we can't see with our eyes. Right, we're going to go drop this into the other board and see if it's all functioning.
Yeah.
I'm going to take another fresh working 555 and drop it into this UCNC board. We've got this dial which changes the speed, just like that blue one did there. Now what I need to do is connect the logic analyzer to this and maybe take some power off of this board to here too.
Got it.
I have wired up the UCNC board where I'm using this breadboard power supply to power it. So this white probe is actually just bringing power to pins 4 and 8, which are connected on this. So that's power in. The red pin here is connected to the probe. I've connected a ground share here, so this one is ground and this black one is ground. And I'm going off ground off of this rather large diode here. Do you want to turn it on or shall I? And I'm just going to check. Nothing's getting hot. Good, nothing's hot.
Good. It's very cold though.
and see if we're getting PWM off of this. It should be doing something. Oh,
right.
When I try and capture, I'm not seeing an awful lot here. So there's a straight line that's up. But do you remember just now we zoomed right in to see the other one that was very fast? So what happens if we zoom right out? So zoom right out. Oh, it's still a straight line and it's up. That's not good. Maybe my probe is in the wrong place. I'm going to try probing on here, which should be a ground. Oh, here we go. So just make sure this is okay and start again. See if we can get anything there. Oh, we got some noise on channel 2, but there we are. Ah, look. And we have our signal. Can you see it? So let me turn this way and try that signal again and see what we get. Can we see the signal, John? And that means we have a working 555. There it is. So now this board here is now making a wave we want it to. I think we fixed it. Right.
But I think it's going too fast.
Well, maybe, but remember, it's got to spin a very fast motor. So that's about right. And if I carry on going all the way down here, let's go as far down as I can. Let's try it. Let's should see now we're going to get more time off than more time on. So the motor will be going slower with more off time. There we go, look. Now it's interesting, look, we got this 1, 2, 3, then a gap 1, 2, 3, and I don't think that is the 555. I don't know if that's the 555 or the logic analyzer. We are right up at the speeds that this logic analyzer has trouble analyzing at this speed, okay? But anyway, I think we're in a good place.
What happens if it's like very high?
If it's very high, okay, well, you want to turn it the other way then, all the way the other way. Let me turn it on. Okay, start. Okay, there, look, it's nearly on all of the time, and it's not off for much of the time. So it's the opposite way round now.
Oh,
happy?
Yeah.
Cool. So we are now happy that this board works with a fresh 555, and the socket there means the 555 can be changed if it has a problem. I guess the only thing left to do is for me to try it on the real CNC. I'm not going to do that in this video, because this video is long enough already, but I will do that before sending it back to Lee, and if there are any further problems then there'll be a further video. If it works perfectly, maybe I'll just add a little clip of that. For now anyway, if you like this video,
give us a thumbs up. If you hate this video, give us a thumbs down.
And what do you do if you want to see more, John?
Subscribe.
Cool. And if you want to help me making more videos and doing more cool stuff in my lab, you can also go to patreon.com/OrionRobots, where you can help me, and also there'll be some perks, there'll be some early videos and some extra information.
I could show you how to do a double thumbs up, maybe.
Haha, double thumbs up.
Double.
Okay.
Together.
Bye.
Hello.